Through the ages, the Baltic Sea has connected people and countries. For hundreds of years, goods and commodities, as well as travelers, have crossed its waters on boats and ships. Over time, the Baltic Sea has become increasingly important for bringing businesses and people in the neighboring countries closer together. This development also includes securing and stabilizing the supply of electric power in the region. 10 years ago, the three Baltic countries had no interconnection with Nordic or Northern European power grids. Strengthening the link between the Nordic and Baltic electricity markets makes it possible to utilize their combined production resources in a more effective way, which benefits both the economy and the environment. In addition, having several energy suppliers improves energy security, as well as the reliability of the electricity supply. These are important aspects for both industry and other end consumers. The NordBalt project will produce and install a 700 MW, 300 kV high-voltage cable system between Sweden and Lithuania, as well as 2 converter stations. The interconnector stretches more than 450 kilometers, approximately 400 kilometers of which comprise an undersea installation. The cables run from the converter station in Nybro via Sandvik on the Swedish coast to the Curonian Spit on the Lithuanian side of the Baltic Sea, where it crosses the Curonian Lagoon before reaching the converter station in Klaipėda, approximately 9 kilometers away from the lagoon. The possibilities of connecting Lithuania and Sweden using high-voltage cables were first analyzed in 2004. An agreement between the 2 transmission system operators, Lithuania's Litgrid and Sweden's Svenska Kraftnät, was signed in 2010. Shortly thereafter, the preparatory work started, with ABB as the turnkey supplier of the cable systems and the converter stations. The European Union has contributed €131 million in funding to the project, which is approximately 1/4 of the total investment. Converter stations were built simultaneously on both sides of the Baltic Sea. Meanwhile, the cable system was produced at the ABB factory in the coastal city of Karlskrona in the southern part of Sweden. Projects of this scope and size require highly specialized equipment and facilities, as well as the right kind of competence for developing and producing such a large amount of high-voltage cable, on time and with a high degree of quality. High-voltage direct current (HVDC) is a proven technology which allows for the long route lengths required while maintaining low transmission losses. The core of the cable, or the conductor, transfers the power and is made of stranded aluminium wire. It is insulated by a layer of cross-linked polyethylene called XLPE. It is confined in a lead sheath, which protects it from seawater. After being reinforced with a polymeric sheath, the cable is fitted with an armor of galvanized steel wires to protect it from mechanical damage. All cable is tested in the factory and then loaded onto the installation vessel berthed outside the factory. The underground cable is transported by HGV in cable drums. On the Lithuanian side, approximately 13 kilometers of cable has been installed on land. One challenge has been crossing the Curonian Lagoon, which stretches alongside the Lithuanian coastline. 2 steel pipes, each with a length of approximately 1,600 meters, were laid under the lagoon prior to the cables being hauled through by means of a powerful winch. The route then continues across the Curonian Spit and on into the Baltic Sea. The cable installation vessel is anchored off the Lithuanian shoreline with a load of submarine cable. The cable is pulled on shore from the vessel and connected to the land cable. While the installation vessel travels towards Sweden, the cable is fed out along the route and placed on the seabed. A specialized underwater vehicle follows the cable in its tracks and uses a water jet to create a trench where the cable comes to rest, buried by redounding bottom sediment. Once the payload has been laid out, the vessel returns to the cable factory to reload with a new length. The new length is jointed to the cable already installed, and the installation process continues. The procedure is then repeated until the vessel reaches the land site on the opposite side. When the installation vessel reaches the Swedish coast, the end of the cable pair is offloaded on floating air-filled buoys. A trench has been dug out to lead the cable to shore. Once offloaded and in position, the cable is then attached to a steel wire and pulled in toward and up onto land using a winch. The route continues underground along dugout trenches. The skilled work of jointing the cable lengths on land takes place in purpose-built workstations that provide for cleanliness and an efficient industrial environment for the delicate jointing work. After the removal of the jointing sections and refilling of the cable trench, there is no visible trace of the buried cable system. At each end of the route, the cables are connected to a converter station. The stations have two purposes. Firstly, to convert alternating current from the power grid into direct current to be transmitted through the cable system. Secondly, to convert the direct current back into alternating current on the receiving side, which is then distributed to the receiving power grid. The NordBalt project integrates the joint Baltic electricity market with the Nordic and European markets. Hence, it constitutes an important step towards the EU goal of a single European electricity market. Furthermore, this €552 million project offers several important benefits to industries and households on either side of the Baltic Sea. NordBalt will facilitate power exchange and increase opportunities for both import and export of electricity, make electricity production more effective to the benefit of private and public enterprises, as well as the environment, strengthen and secure the distribution of electric power in the Baltic countries and in southern Sweden, ensure a stable and reliable energy supply in the region.